Hello and welcome to another episode of Indian.net where we are going to discuss about AWS Serverless, and that session will be delivered by Mohit Salecha, who has close to 8+ years of experience. And before jumping into directly into the AWS Lambda, let's discuss first who we are. So we are Indian.net community, Indore based, and we are running multiple different community also, like Indore software developer community, Indian.net community, in the SQL Pass, and the Power Platform, and there are multiple other aspects we are doing. So why, if you are not joined our community till now, I would request, please do join our community. We are available on Facebook and WhatsApp group as well. Details are scrolling down on your screen. And if you are not aware what community can help you, so let me tell you. The first thing is like every Sunday we are giving some sessions, and there might be on Saturday also sometimes. So it's a free learning sessions, so you can increase your knowledge by connecting with us. On the same time, like we have all the members who are currently joined us, those are the technical people, so they might help you in giving you technical guidance, as well as like there are a lot of opportunity that which they share in the group, so you can avail those opportunity and take the help of the seniors over there. Along with that, this when you are joining this community or sessions, we are providing, if you are fresher, then we are providing you the certificate which you may use for your LinkedIn profile or your resume. That would help and give extra wattage to your resume. Along with that, this platform is free for all, firstly, so we giving the equal opportunity to everyone. If you have like something in your mind which you want to share with the community, feel free to do that. Just drop an email or chat, or might be WhatsApp us, like you want to take some session, want to share some knowledge with the community, please feel free to do that. Okay. With this said, I would like to welcome Mohit, and he is like giving today's session, which is one of the interesting session, AWS Lambda. Over to you, Mohit. Thank you very much for joining. So, hello, Mohit. Your voice is not coming.
Oh, is it audible, Rajat?
Yeah, now it's audible. Yeah, thank you.
Perfect. Thank you, Rajat. Thanks for having me. Hello, everyone. Hope you all are doing very well. And yeah, as Rajat said, it's a really great community. I've been part of this community since like last 8 year when I joined my first company, and I'm learning too much from there. Not only in field of what I'm working, but also what happening around the world. So yeah, feel free to reach out any of us. And yeah, let's start today's session. Lambda or Aka serverless technology. So as you all know and aware that serverless is something a nicely pitched thing with cloud computing. What serverless? Are they really without server? Things are running without server. We all will solve this doubt for you here. So first is our Lambda. So Lambda is nothing but a compute engine. As all of you are aware about how this computing thing work, how this cloud is working. If you are not, just try to go back few more sessions we have done on different AWS services. So again, this is there are three main parts of an service. One is compute, storage, and another is our uh, API gateways. So compute is something essential part where we do all the computation, what your CPU is doing. So Lambda is something which is our serverless, where we run the code without managing any servers. Right now, if I talk about really well organized companies, they do have their own servers. Few of them purchase VPCs, but they also have to take care on the updation of server, on the licensing part of each different platform they are working with. So here the solution is Lambda for you. If you have really small job, go for go for Lambda. I will say you never regret it. So when building serverless application, AWS Lambda is one of the main candidates for running your application code. Typically, For a compute and complete serverless stack, you need a compute service, a database service, and a HTTP gateway service. So this create a complete engine, end-to-end customer engine. So we have DynamoDB in AWS. Then we have compute engine as could be EC2, could be Lambda. Then we have API gateway, HTTP gateway, where all our requests came directly to this gateway, directly to compute engine, and compute engine will take care of further computation. Languages support. So it's really huge stack of languages supported by Lambda, and it's still growing. I will say it will not gonna stop at this point. It will grow beyond this. So if you see this, AWS Lambda currently supporting Node.js 3 versions, 8, 10, and 12. It's still further developed for Node 16. Then we have Python 2.7, the majorly and most of Python developer using this right now, along with 3.6 and 3. Till 3.8. Then we have Ruby. Then we have Java 8 as an open source and Java 11 support with AWS Lambda. We have Go 1.x, which is the latest version for this. And also right now it's like .NET Core 2.1. Also we have .NET 3.1 supported with Lambda and PowerShell 6.1. Also with Rust framework, AWS Lambda also providing some custom integration of runtimes, which we can explore further. Not in this session, maybe in our advanced sessions. Then why serverless? First and foremost, no worries about the server. You don't have to worry about the server, about the IS server, if you need to purchase it or not, whether you need to manage your servers that frequently or not. What else? Updation of softwares, updation of vulnerabilities. Right now, we know how this hacking world is growing along with the application. So you don't have to take care on those vulnerability of servers. Automatic scaling. So Lambda is designed in such a way where you, for each request, it initiate a new instance of compute engine. It basically inside a container, and there are multiple containers working parallelly for this. And speaking out about Lambda, there could be 1,000+ instances at the same time, and that can be initiated more with few more tweaks. Then third part is pricing. What one need while at initial stage or at major stage, the server cost. We all know server cost increase rapidly when we move forward or when we scale our business for computation. But Lambda gives us a positive way for that. Here we have metering on seconds. Your each millisecond is countable here. So you don't have to pay for any dead Lambda services. You don't have to pay anything. If you have 1,000 Lambda services resting there, it's fine. It's totally free of cost. You only have to pay when you utilizing those services for computation. So that's how this metering works for AWS. Everything came with some limitation among them, and Lambda also came up with some limitations which can be tweaked up, but up to a certain limits. So here are a few limitations we can see with Lambda also. One is cold start time. So as you all aware, like for each instance of a service, we have it generate a new container, it initiate a new container, and then it runs the function. So if let's suppose let's say your function stays for like 15 minutes, and then it turned it off, the container services. But when you want it to, so it basically takes 5 to 10 seconds, not much, but yeah, for highly legacy, I would say critical applications which really require like data in some milliseconds or something, then sometime Lambda have those limitations. But no worries, we have more services for to tackle those scenarios with us. We can came up later on that part also. So here we have few limitations with Lambda. Then functional limit. So each function in Lambda have a limitation of execution runtime. Lambda are designed not for high processing tasks. These are defined for high performance tasks with a small compute time. So each Lambda only compute for maximum 15 minutes. and that's non-changeable right now. So after 15 minutes, it automatically turn off the computation. Then memory, although I will not say it's a limitation, but because the size of the variant options AWS providing with Lambda is really huge, and it's nothing related to availability or something. It's just the kind of function you want to use. For example, Lambda right now comes with 128 MB memory till 3008 MB memories, right? And um, it have a code size packaging of 64 MB at least. Like it starts from that also, and it could be larger. And unzipped version is at most of 250 MBs. So I will say it's not at all a limitation for Lambda, but yeah, if you have some compute engines which require more than 3000 MBs, then yeah, you need to think on again selecting where you need. Do you really want to use Lambda in that? Concurrency. As I said before, concurrency is an initial and critical part of AWS Lambda. In Lambda functions, we know that we at a time we can initiate 1000 concurrent instances to compute a particular function at a time. So 1000, it's it's reuse those instances. We can't say that only 1000 requests will be served. It reuse the existing 1000 instance. But so if you think like you have millions of requests a second, then we need to tweak this thing. And I will not say there are no solution to improvise it from 1000. There are many tweak available on internet. One can like really get them up through getting different use cases running on Lambda. Okay, payload size. So yes, Lambda have a limitation with payload size. So actually, that's a limitation from API gateway. We all know that API gateway is an interface we use to trigger Lambda further. And yes, here comes a limitation of 10 MB on payload. It's not much. It's not, I will say, really less, and not much. It's a perfect thing to be managed. 10 MB, if you have really huge storage, I will say, in my personal experience, never go with more than that. Like 10 MB is too much for someone who want to transfer some data as a request payload. Always use S3 buckets to store your data and then use it through Lambda. We doing it with one of the largest truck manufacturing company. Rajat, sir, any questions so far, or anyone? Hope these things are clear till now.
Yeah, one question from Rupesh. Is AWS
Yeah.
Lambda similar to Azure event or function?
Yep. Yes. So AWS Lambda is quite similar to Azure event less functions, and I will say it's kind of more mature, and it's again a serverless competitive service providing far before than Azure. Yeah. Anything else?
No, we are
Okay.
good.
Let's move forward then. Hope these things. Pricing, as I said before, like pricing is really competitive what AWS is providing right now. So for a starter, for if you are aware about free tier, then AWS free tier is all the Lambda requests till 1 million request is completely free for AWS Lambda. And also if you see this, pricing is for $0.2 per 1 million requests for free tier. Then function and memory runtime, it's again per GB second, and it's really less as compared to any other services which are running full time, and you don't have to pay while the services are idle. So if say your consumption is really low or you want to do some specific consumptions, then go for AWS Lambda. You never regret this thing. Outbound, all these pricing activities, I will share a link from AWS doc. You can find them there. Then we can have like multiple inbound traffic limitations, which is have some limitation with that. Amazon API gateway. So here I why I put Amazon API gateway, because if you want to run Lambda function from let's suppose uh, and out through Postman or through mobile app, then you may need API gateways there. And yes, API gateway came up with really low cost, like $3.5 for a million requests. It's not huge. Okay, let's okay. So let's move to AWS Lambda functions. How Lambda works, right? So if you go to AWS console, you can just need to type this Lambda. Here you we will get a link for AWS Lambda. Okay, inside this, these are the major runtimes provided by Lambda and supports by Lambda. Node.js is one of the common and most used runtime for Lambda. Now .NET Core is something which is really evolving themselves and coming with this. Okay, so here is a really small function already created with the handler. Handler is something, a function with the which is I will say exported for Lambda function. So this function is been derived as a function which will be triggered for Lambda. And when I run this function, you can see directly, okay, it will print hello from Lambda. Next, how this computation works. So here is a really well managed example how different services can trigger a same kind of Lambda for different kind of processing. So you see streaming analytics. So we have, let's suppose we have an application which is streaming some particular data and we want to analysis on those live streams. Then yes, Lambda really works well in such streaming functionalities. This being managed by Coca-Cola itself and many other use cases already on web with this. If you want, let's suppose mobile, then we can have a mobile IoT backend as a serverless, which triggers Lambda. And you see, if I trigger, let's suppose many more requests here, if you see the count, then it just increase the instances. So these all are the instances which are managing the different requests. So let's suppose we have some capturing and we want to do some image processing on this. Yes, Lambda came a really less compute, less pricing solution for your those compute engines for data processing or image processing. Then scaling. So if you see for like 1 lakh request, 2 lakh request, it's really low cost. But the cost only increase when we see huge amount of requests coming to us. Obviously, request equivalent to business in IT terms, right? So yeah, and it's quite less. If you say it's like 4 million requests right now, and we still have only have to pay like $6 or $7. So it's not much as compared to other services which are costing for this the same kind of service. Okay, and yeah, Lambda can be two types. So one will be an event-based Lambda, and one will be a function Lambda, which work as a request response manner. Event-based, you can subscribe those event-based lambdas for either from Lambda itself or either from SNS or SQS services. Then secondly is our request response. So when you want to trigger a single request, if any one of you have heard about minimal API recently introduced by .NET Framework 6.0, then those minimal API can take in it's something an initial part of Lambda, which we already working with Lambda. So it's something a single function operating all the computation for you at one time with a request response. So you can have an API gateway to doing so. Okay, so let's start with the creation of a new function. So AWS provides a really nice UI where you can either bootstrap a new function from the scratch or you can use an existing blueprint. It contains really huge amount of blueprint. Like there could be microservices, different kind of. There could be HTTP calls, request response in different languages. There could be streaming. If you want DynamoDB with streaming services, you have those sample already created with Lambda in when you try to create a new function, you already find them. We just go right now as introduction. We're just going with the basic hello world function from our side. Here is a Node.js hello world function. Let's just start configuring it now. Execution roles. If you can see here, we have different kind of role. First is create new role with basic Lambda permission. What are Lambda permission? I believe you all are aware we have IAM role derived for each kind of request in AWS instance. Again, this is a similar kind of request we need to manage with this. Each Lambda contains some roles and Lambda can't process beyond those roles. The basic Lambda roles mostly contains reading, writing from S3 buckets and like only the basic role and execution the Lambda. Then let's suppose you want some custom things and you already have an existing role for that. Then we can use this function uh, the radio button for by selecting use an existing role and select if we have any existing role from this drop down. Third is like create a new role with AWS policy templates. There are few again some policy templates provided by AWS where we can see like read only operations, batch access, cloud formation stack. So these are some basic S3 object. So these are some of the basic policies which are provided by AWS, and we can create a role at the same time for this. Right now, we're creating it with some a new role with some basic Lambda permissions. Here is the code. So it's a easiest course. It's currently using Node.js 12.x version, and the architecture will be our 64, 8664 support architecture. Here we have two different parameter. One is event, one is context. Event is something which contains different parameters which we want to utilize here. Could be params also, as different kind of param being provided here. Second is context something the whole context of particular lambda. So if you want, let's suppose there are, if you want to retry whether that lambda failed or not, that can be managed through context. All the documentation is available on AWS docs for each methods and function available in this context. Similarly, for events, create function. That's it. Is that easy to deploy a new Lambda function in AWS? It's take a little small time to trigger it up, and here you go. A new Lambda function is ready for your execution. Few things to remind again. Lambda function can't be called directly from outside the REST API. If you want to call it as a REST service, we want to integrate API gateway before this, which will trigger our Lambda function. So that's a trigger. A trigger could be API gateway, a trigger could be CloudFormation, CloudWatch, DynamoDB, or a trigger could be our SNS or SQS services. So if you are working with an event-driven programming, then SQS and SNS are quite well used structure. Okay, as I mentioned earlier, kind of memory. Here you can see which kind of memory instance we have created, and if we want to edit it from here itself, we can use this. This is usually in our two on the basis of 2 power, the way we use our RAM. So it varies from 128 till 3008 MBs as per our use. Environmental function, that's really useful thing. So if we want to work with different environments, dev, pre-prod, prod, customer acceptance, yeah, here comes that environment variable for us. Different permissions, this is managed through roles what we provided to it. Okay, code, that's another great thing. So let's suppose I want to change few stuff here. I just added a console log saying, right? And we want to deploy this change directly. So with Node.js particularly, it came up with mostly with the scripting language, it came up with inline editor. So you can have your code here and you can change your code on the go and deploy it that instance at the same time. So if I just give it a test, I will say test the template. Oops, it fails. What the issue? Invalid or unexpected token. We'll go to the code, execution result. We don't want to hear it. There you go. See, I forgot something, and it will save it, deploy it, and ready to test again. Now we are passed. For logs purpose, we can view all the logs in CloudWatch where we have different groups. So there's a separate group for each Lambda, and for each execution, we can see different log streams for most of them. So let's say there are different containers, then there will be different log stream. So log stream are directly proportional to containers. So if I am testing it like multiple times, then you can see there will be X number of log streams generated. If there will, it's all the everything is in the same container, then look, for the same container, it will not generate new log streams. You utilizing the same one. But yeah, there you go. All our logs are here. Any question from anyone? Okay, seems all are fine. So yeah, that's with this only. I would like to wind up my session here, and do join us on nerdtechies and indian.net.wordpress.com. Links will be there in description soon. Thank you.
Hey, thank you, Mohit. Thanks for wonderful session for introduction of Lambda, and hopefully this might help the people. At least a beginner step would be you have provided. Thanks a lot. Thanks everyone for joining. Ending the session now. Thank you very much. Thank you,
Thank
Mohit,
you.
once again. Bye bye, everyone.
Bye bye.